So hi everyone and welcome to Namoona 3D Labs, and in today's video we are going to see the workflow of how you can develop the model and how you can analyze for the injection molding and how you can develop the injection mold. And in the upcoming sessions we will see a practical demo in live of how you can design the detailed model like this one. We'll go by taking a small part such as the front wing, and then we'll analyze for the injection molding aspects and how we can tackle the challenges related to molding and 3D printing. So the process generally starts with creating the 3D model, and then each individual part has to be optimized for injection molding. So I created that in a separate file. You can see that injection mold inserts were developed for the front wing. There are some minor corrections which need to be made, but I will just make you understand what's actually happening. So you can see that there are two halves for the injection mold of the front wing part. And if I hide this one as well, you can see that this is an internal cavity, and if I hide the bottom part and show you the top part, you can see the top portion is having another cavity, and when both of them meet you get the mold. So this is known as a molding insert. And if I hide this and again turn back the front wing on, you can see that there is some slight variation between the front wing which you have seen in this file and the front wing which you are seeing here. So the complete wing portion has been separated from the main body, including the nose as well as the intersection here. They have been separated by creating or modifying the existing design so that it can be molded separately and then assembled. So this is a screw hole using which you will attach the front wing to the nose of the F1 model car, and you can see that the edges have been filleted for consideration of the manufacturability of the part, as well as you can see these two holes wherein the nose pylons will get inserted into that, and then from the bottom when you heat it, it will get locked. And you can see that all the edges here are sharp, but here when you are actually designing it for injection molding, all the edges have been filleted with the radius. So that is one of the aspect, and at the same time any undercuts in the design have to be eliminated. Undercut is any geometry of the part which is intersecting with the drawing direction or the pull direction of the injection mold, which will avoid opening of the mold. So you need to avoid such geometries. So when we speak about injection molding in the upcoming lecture, we will look at how you can eliminate undercuts in a more detailed manner. And once the mold insert is ready, you need to make the design calculations for the injection mold in the third stage. What would be the tonnage, what would be the area of the mold, what will be the height of the mold, and what material you are using, how much shrinkage you need to compensate for depending on the material injected. Such calculations will be done in the injection mold development stage, and either you can machine the base mold or you can machine the insert. Insert is basically a small component which you are seeing here, which can be changed. Let's say for example, if I am changing the model to a new model to meet the customer demands, then I don't need to manufacture the whole mold again. I will only have to change the insert, and once it's installed in the injection molding machine, it will inject plastic into that. And there are the standards which the injection molding companies follow. One is the DME standard, another is the HASCO standard. And if the molds are very costly and you need to reduce the manufacturing cost of the injection mold, you can also design your own molds without following any standard, but it is always advisable that you follow some standard. And before you actually develop the injection mold, you need to also analyze and optimize the geometry by using the mold flow analysis. And inside Fusion 360 you have the mold simulation module. So you can see the results. So basically you select a material and you select the injection temperature and injector location, the gate location, and it is going to display the warpage and any filling gaps or any air bubbles that are forming inside the mold, how much percentage of the mold is getting filled, and are there any visual defects that could be formed in the mold while the plastic is being injected into the cavity. Such analysis is possible using the simulation tool of Fusion 360. So inside simulation you have FEA, thermal cooling analysis, buckling analysis, as well as injection mold analysis. So when we go into that particular lecture, we will be studying that in more detail. So you can see that after the simulation is run in the cloud, it is telling that 90% of the cavity can be filled and 10% is difficult to fill. These are the areas. So you need to change your gate location. So currently I have given this point as the gate. You are seeing a small yellow color triangle, that's the injection point of the gate. So it needs to be changed. Maybe you need to inject plastic from multiple directions to make sure the entire cavity will be filled by the plastic. And some of the visual defects which may have arise during the molding, that also can be predicted using this tool. So based on a certain tolerance limit that is automatically set by the software, it is going to tell you if you will be having any weld lines. So weld line is nothing but when two different flow streams of plastic will meet together at one point, and when they cool down, it is going to create a visual mark which is called as weld line. You can see some lines are being formed here at the midsection of the wing. So that is one of the defect that will be formed. So in order to eliminate the defect, you need to inject plastic from the center and allow it to move outwards. So such considerations, you need to optimize the design, or you may have to split the bodies into multiple bodies and then develop the injection molds for it separately, and only then you can finalize the design of the mold and send it to the molding companies. And you can also analyze the warpage. Warpage is nothing but deformation when the part will be cooled inside the mold. So there will always be some amount of warpage when the hot plastic will be cooled slowly, and warpage cannot be eliminated completely, but it can only be minimized if you optimize your design properly. So when you do several design and simulation activities and practice it, you will get some idea of how you can eliminate the defects and how to modify the design. So you need a lot of imagination and forward thinking, and it's not always possible to eliminate warpage. You should make sure it does not affect the functionality and look and feel of the part. And you can see that the warpage for this particular rear wing, as per the software, it's showing as 0.46 mm. That's the maximum deflection of the part. So that's less than 1 mm. It is somewhat acceptable, but if you still want to make the model to its perfect shape, then you need to change the geometry. Maybe you should increase or decrease the thickness and maintain the uniform thickness along the geometry. You can see that the rear wing, the end plates is having a different thickness, and in the center it's having a different thickness, and at the base it's having a different thickness. And this is the main reason, could be one of the reason for part warpage. And if you make the part with uniform thickness, then the warpage can be minimized. And in the second series of the sessions, we will see how you can develop the observation skills to develop a practical diecast design. So you need a lot of imagination and observation skills by looking at the pictures. So all these diecast manufacturing companies, what they do is they hire designers, and the job of a designer there is two-folded. The primary aspect is to imitate a given model to as much accurately as possible, and then to incorporate the injection molding constraints onto it, and then forward it to the mold tool developers. So the companies might be partnering with other mold tool developers, or they might have their own dedicated team depending on how large the company is. And learning these skills will definitely help you not only in the particular automobile and diecast manufacturing companies, but also other companies which involve in plastic injection molding. So see you in the next session.